So, based on our discussion from the density curve for x bar, we can say for 95% of samples, mu minus x bar, that's the distance between the mean and the sample mean, has to be between 1.96 sigma over root n. That's if the sample mean is that far below the true mean, or minus 1.96, that would mean x bar is that far above the true mean to get that number. So that system of inequalities, if we solve that for mu, just by adding x bar straight across, we get x bar minus 1.96 sigma over root n is less than mu, and x bar plus 1.96 sigma over root n is greater than mu for 95% of samples. So we call this corresponding interval here the confidence interval for this population mean. We have the shorthand for the interval here. Since we're adding and subtracting the same quantity to make the interval, we write it as x bar plus or minus. You would think that's just two numbers, but we're thinking that's an interval, the upper and lower bounds for an interval. And that's called a 95% confidence interval for the mean. Practically speaking, if we don't like the math, we'd say x bar is close to mu. So if you reach out far enough on each side of x bar, then most of the time, so for most of the x bars, you reach out the right distance, you're going to go over there and create an interval that catches mu. We say there we are 95% confident the interval contains mu. That means that 95% of samples the interval contains mu. And call 95% the confidence level C. We're going to use C for confidence level for intervals. So C equals 95% for this type of confidence interval. And the way we know it's 95% is because we use 1.96 here. And that 1.96 was the distance you had to go away from the mean and standard deviations to capture 95% of the values. So if you wanted to be more confident, I guess we use a different z-value, and we'll have a table to look up those z-values, but that's the most popular one. 95%, 1.96 shows up there. All right, so we made our first steps towards creating a confidence interval. The most popular one, if they don't tell you a confidence level, you're going to use 95%. Just as the default level of confidence people use for confidence intervals. So you now are dangerous enough that you can make a confidence interval and tell your clients that I'm pretty sure the population mean falls in this interval because I just made a 95% confidence interval.